right, so let's continue. LDC has R and X setting, which are both adjustable to between the range of 0 to 24 ohms. And these R and X settings that is adjustable allow us to measure the voltage at SRP. So SRP can be adjusted. It can go further. It can come nearer to the regulator. So in order for us to measure the voltage at SRP, then we need to have various settings of R and X so that we can adjust SRP at any point along the feeder, right? If that makes sense to you. So let's continue. And then the BW, the bandwidth of the VRR, okay, is adjustable to between the approximate range from 3/4 and 1.5 volt base on 120 volt base. The TD, which is the time delay, is adjustable to between about 10 and 130 seconds. And this TD we are not going to use here because our focus is voltage regulator. The time delay, we will only use it in the protection system chapter in the next one. Yeah. And the location of the RP is controlled by the RX setting of the LDC, as I mentioned just now, right? So the LDC, you have various R and X setting. And this R and X setting allow us to measure voltage at any RP, at any regulating point on the feeder. So if R and X are set to 0, then the regulator regulates the voltage at its local terminal to the setting of the VRR plus minus BW. So in this example, SRP equals to S1. ANSI standard provides for regulator overload capacity as listed in table 9.2 in case of 10% range of regulation is not required. All modern regulators are provided with adjustment to reduce the range to which the motor can drive the tap changer switching mechanism. Good advantage sometimes can be taken of this design overload type of limited range operation. However, if load growth occurs, both a larger range of regulations and a larger regulator size can be expected to be needed. So table 9.3 gives some typical single phase regulator. So what it means is this, yeah? This is a typical single phase regulator size. So the single phase regulator can range from this size to this size. If you want a 3-phase one, then you multiply this value by 3. And the accompanying information are the voltage and current rating, and also the current transformer and potential ratio. So the definitions of the current and potential transformer ratios are given over here. So I mentioned just now, the regulators have VRR, has LDC, and the LDC can adjust its R and X setting based on current transformer and potential transformer inside the LDC. So the R and X that is adjustable inside the LDC allow us to measure voltage at any of the regulating point along the feeder, right? And this information just for it's just for your information. We are not going to use this in our analysis later, but it's good to know. And the regulator, if we allow the regulator, okay, to regulate the range of the voltage to between plus minus 10%, meaning that our tolerance is larger than the loading, okay, of the relay or the regulator will be less, which is up to only 100% of the normal load current. But if we allow the relay to adjust voltage, okay, to regulate voltage to a more tight range, for example, plus minus 5%, then we can allow a higher normal current loading, which is 160%, up to 160%. So this is the end of the first part of the video. In the second part, we will go through the analysis of the example.